Hello, Chem students. In this video, we want to start looking at intermolecular forces. Intermolecular forces. So, attractive forces that occur between molecules. Just like interscholastic sports when we play other teams. So, I wanted to highlight two different types of these IMAFs today with hydrogen bonding and dipole dipole. And then in another video, we'll look at other intermolecular attractive forces. So let's look at the three things I've drawn up here. Of course, you recognize water molecules and the ability that water molecules have to attract each other. That intermolecular force is called hydrogen bonding. And we know that water is polar because oxygen's more electronegative than hydrogen. And so the hydrogen becomes partially positive and this becomes partially negative. This is a pretty strong intermolecular force. It can explain a lot about water. It explains why it'll bead up, why it has a high boiling point, why it evaporates really, really slowly. If you spill some water on a countertop, it'll be there for a long time. So that's a pretty strong intermolecular force. One thing you can think of is this difference in electronegativity is really high. So these deltas are pretty high. These partial charges, pretty high, pretty great. Okay, so here's another example of where hydrogen bonding is occurring. So we have hydrofluoric acid molecules, and they attract each other. Why is that? Well, fluorine's very electronegative. It's the most electronegative element, right? So we draw a dipole like this. This is partially negative, partially positive. So this hydrogen is partially positive, partially negative. So again, that's hydrogen bonding right there. That intermolecular force between those molecules, hydrogen bonding. All right? Another example, ammonia. Ammonia molecules will attract each other which is called hydrogen bonding. And the reason that is because it has an NH bond. This NH bond, nitrogen has a really high electronegativity. Hydrogen's pretty low. So again, it's a dipole like this. This side of this molecule is partially positive, and the nitrogen, this nitrogen here, partially negative, so they'll be attracted to each other, ammonia. So these are three examples of hydrogen bonding, and like I've said in some Zoom sessions we've had, just look for these bonds. And I always think of NOF here, NOF. So look for an HN bond, HO bond, HF bond in a molecule, then think hydrogen bonding. So think about all those alcohols. Every alcohol has an OH group, so there's going to be hydrogen bonding in all alcohols. Here's hydrogen peroxide. Hydrogen peroxide has two OH bonds, so think hydrogen bonding between hydrogen peroxide molecules. Okay? All right. A weaker but still significant intermolecular force is dipole dipole. So the ones I have below the dotted line, dipole dipole. This is formaldehyde. And you can tell this molecule is polar. It's not symmetrical. We know that these hydrogens are partially positive, and this oxygen is partially negative. Okay? So this partially negative oxygen is going to be attracted to this side. Just like that. And this attraction here, it's called dipole dipole. So one dipole, this this tip of this dipole is attracted to this tail of that dipole. So I think the name is pretty appropriate. Dipole dipole. Here's another example, hydrogen sulfide. I think my set 5 class can relate to this molecule. I'll just leave it at that. So hydrogen sulfide, these guys attract each other. It's a polar molecule. Sulfur's more electronegative than hydrogen. It's not as electronegative as oxygen, because look, if on the periodic table here, sulfur's below oxygen, so it's not as electronegative. But still, we have these dipoles, partially negative, this is partially positive. So this whole side is partially positive, and this is partially negative. So they attract each other, and that's called dipole dipole. So if you have a polar molecule, and you have one of these 3 bonds, think hydrogen bonding. If you don't have these 3 bonds, then if it's polar, an intermolecular force that contributes to a lot of its properties would be dipole dipole. Hydrogen bonding stronger than dipole dipole. And what these intermolecular forces affect are a few things. It affects how fast things evaporate. It affects its boiling point, its solubility, and its viscosity. So as intermolecular forces go up, as the attractive forces between molecules increases, its ability to evaporate, to turn from a liquid to a gas, is going to be less. Boiling point. So for molecules to go from liquid to gas, again, the greater the attractive forces, the boiling point's going to go up. The boiling point goes up as the IMAF goes up. Solubility, what I'm talking about here is its ability to dissolve in, say, water is significant in terms of it being polar. Viscosity, its ability to flow. Like honey has a pretty high viscosity. So the more intermolecular forces, the stronger the intermolecular attractive forces, we see that things pour more slowly. So the viscosity would be higher. In fact, if you think about hydrogen peroxide versus water, hydrogen peroxide has 2 OHs here, so it would be a little more viscous than water. So I think we'll be generally talking about, we'll be focusing on boiling points the most with regards to intermolecular attractive forces. Okay, so hydrogen bonding and dipole dipole. Next video, we'll go into, we'll make sure you understand London dispersion forces, and then look at dipole-induced dipole and ion-induced dipole. And I think that's it. All right, thanks.